Hello students, myself Sarama Malik Das, Assistant Professor of Gargi Memorial Institute of Technology. Uh, Today I discuss about the permutation of rows and columns of an incidence matrix. In my previous lecture I discussed about what is incidence matrix. Now I discuss about the interchange of rows and columns of an incidence matrix. Okay. Permutation of rows and columns. So what is permutation of rows and columns of an incidence matrix? The interchange of rows or columns of a matrix are known as permutation of rows or columns of the matrix. Okay, so using this we have a theorem, that's two graph G1 and G2 are isomorphic if and only if the incidence matrix of one is obtained from that of other by permutation of rows and columns. Okay, so for example, let we have a two graph. Say this is V1, V2, V3, V4, and there are two vertices, say V5 and V6, and it is edge E1, E2, this is E3, this is E4, and this is E5. Okay, and this matrix is U4, U5, U6. So and this is A1, A2, A3, A4, A5. So the incidence matrix of the two graphs are incidence matrix of the two graphs are, say this is G1 and say this is G2. So A of G1, that is equals to, here 6 vertex, that means 6 rows, V1, V2, V3, V4, V5, V6, and 5 edge, that means 5 column, E4, E5. Okay, so E1 is between V1 and V2, others are 0. E2 between V2 and V3, others are 0. E3 between V3 and V4, others are 0. E4 between V4 and V6, others are 0. E5 is in between V4 and V5, V4 and V5, and G2, here also 6 vertex, so 6 rows is there, and 5 edge, that means 5 columns are there. So A1 is in between U1, U2, others are 0. A2 is in between U2 and U3, others are 0. A3 is in between U3 and U4, others are 0. A4 is in between U4 and U5, others are 0. A6 between U3 and U6, others are 0. Okay, so these are the two incidence matrix. Now we are going to investigate that whether AG2 can obtain from AG1. Okay, so we see here first three column of AG1 and AG2 are same. To make the fourth column identical, we interchange fifth and sixth row of AG1. Okay, and we get matrix B. That means B is equals to 1 1, this, fifth and sixth. So fourth row also same. Okay, so this, that means from B and AG2 all the fourth column are same. Now the first fourth column of AG2 and B are same, the only fifth column is different here. Okay, so first fourth column of AG2 and B are same, only fifth column is different. So we conclude that AG2 cannot be obtained from AG1 by permutation of rows and columns. So the two graphs G1 and G2 are not isomorphic. Okay, clear? Now we have to find out another matrix of representation of graph, that is adjacency matrix. Okay, so of a graph. Now let G be a graph with n vertices having no parallel edges the matrix capital X equal to Xij n cross n is called adjacency matrix of G. If Xij is equals to 1, if Vi and Vj are connected by an edge and equals to 0 if there is no edge between Vi and Vj. Okay, and if there is a self loop at Vi, then we suppose Vi are connected by an edge. Okay, so for example, we have to find out the adjacency matrix for this graph only. Say this is a graph. This is V1, V2, V3, V4, V5 and V6. E1, E2, E3, E4, E5, E6, E7, E8. Okay, so here the adjacency matrix is the combination of vertex. Okay, and it is a square matrix. So the adjacency matrix of the given graph is here 6 vertex is there, that means V1, V2, V3, V4, V5, V6, 6 rows and 6 columns. Okay, here V1 is connected with 3 vertex. V1 is connected with 3 vertices, V2, V5 and V6. So at that position only 1, others are 0. Okay. Similarly, V2 is connected with V1, V3 and V5. V1, V3 and V5. Others are 0. Sorry, V4 is there. This is 0. Okay. Next, V3 is connected with only V4. V4. Next, V4 is connected with V2, V3, V5 and V6. V2, V3, V5 and V6. Next, V5 is connected with V1, V2 and V4. And V6 is connected with V1 and V4. Okay, so this is our adjacency matrix. Okay, and we find the graph from the adjacency matrix also. find the graph from the following matrix. Okay, say the matrix is this: 1 0 0 1 0 0 1 1 0 1 1 1 1 1 1 0. Okay, this is our matrix. Okay, now we put here the vertex, as there is 4 row and 4 columns, so there is 4 vertices V4. Now put the vertex V1, V2, V3, V4. Now here V1 is connected with V1 and V4. That means V1 have a self loop and it is connected with V4. V2 is connected with V3 and V4. V3 and V4. V3 is connected with V2, V3, V4. V2, V3 and V4. V4 is connected with V1, V2, V3. Okay, so this is our graph. Clear? Now we construct the adjacency matrix for the diagram. Okay, now let G be a digraph with n vertices V1, V2 up to Vn, having no parallels edges. Okay, then the matrix capital X equal to Xij by n cross n is called adjacency matrix of G if Xij is equals to 1, if there is an edge directed from Vi to Vj and is equals to 0 otherwise. Okay, so for examples, say it is example 3, we have a graph, we have a directed graph. Okay, this. So this is not a parallel edge because the direction is different. Okay, so write the vertex name, say it is V1, V2, V3 and V4. Okay, so 4 vertices there, that means this is a 4 by 4 matrix. Adjacency matrix is a 4 by 4 matrix. Okay, so find here V1, V2, V3, V4. V1, V2, V3, V4. See here, V1 is connected with V1 again, so it is 1, and from V1 V1 is connected with from V1 to V3. There is an edge directed from V1 to V3. V1 to V1 and V1 to V3. So V1 and V3 position is 1, others are 0. And again V2, from V2 there is a edge from V2 to V1 and V2 to V3. V2 to V1 and V2 to V3. And from V3 there is an edge from V3 to V2. V3 to V2 and V4. Okay. And there is no edge from V4. Okay. So this is our adjacency matrix. 4 cross 4. Okay. Similarly, from the matrix we can draw the graph also. Now, how can we find the adjacency matrix of a disconnected graph? Disconnected graph. Let G be a disconnected graph or digraph, whatever, having two components G1 and G2. Then the adjacency matrix of G can be written in a block diagonal form as x of G is equals to x of G1 O x of Z2, where x of G1 and x of G2 are the adjacency matrix of G1 and G2 and O is a null matrix. Okay, now we will illustrate an examples. Say, construct the adjacency matrix of the following graph. Okay, so for this graph, so this is a graph A, B, C and D. Okay, so it is G1 and E, F, G, H and it is G2. Totally it is G. Okay, so G is a graph and there is two components G1 and G2. G1 has 4 vertex A, B, C, D and G2 has also 4 vertex E, F, G, H. So first we have to find out the adjacency matrix of G1. Okay, so as there is a 4 vertex, so it is a 4 by 4 square matrix. Now A is connected to B, so this one. B is connected to C, so this B is connected to A and C, sorry, this. C is connected to C, B and D, C, B, C, D and D is connected to only C. Okay, so this is the adjacency matrix of G1. Next we find the adjacency matrix of G2. Here also 4 vertex. E is connected to F. F is connected to all these E, G, H. G is connected to only F. and H is connected to only F. Okay, so these are the two matrices of G1 and G2. Now we find the total matrix, that is Xg. This is the block diagonal matrix. Which is equals to A, B, C, D, E, F, G, H. Now A, B, C, D, E, F, G, H. Okay, this is the 8 cross 8 matrix. First one, A, B, C, D. Okay, this is 0 matrix, that means null matrix. This one is also 0 matrix. And now this matrix 0 1 0 0 1 0 1 1 0 1 0 0 0 1 0 0. So this is the final adjacency matrix of the disconnected graph. Okay, now we can find the adjacency matrix, we can find the graph from the adjacency matrix also. Say, construct a graph whose adjacency matrix is given as this 0 1 0 0 0 0. Now 1 0 1 0 0 0 0 1 0 0 0 0 0 0 1, this one. Okay, since the matrix is a 6 by 6 matrix, so the graph contains 6 vertices. It is a block diagonal. See, this is a block diagonal matrix. Okay, say this is a block diagonal matrix. Okay, and it is a 6 by 6 matrix, so it have a 6 vertices, say v1 v2 v3 v4 v5 and v6. Okay, so from one block, it is a block, as it is a block diagonal, that means it is disconnected. Okay, so from the first block, that is 0 1 0 1 0 0 0 1 0, from this block the graph will be it is not symmetric, so it gives the diagram. Okay, so from this it is not symmetric, so it gives a digraph. Okay, that means v1 v2 v3 V1, V2, V3, V1, V2, V3. V1 is connected to V2, this one, and V2 is connected to V1, this one. As it is a adjacency matrix, V1 to V2, V1 to V2 and V2 to V1. Then V3 is connected to V2, V3 is connected to V2. Okay, so this is our graph from the block, and from the second block, from this block 0 1 0 0 0 1 and 1 0 0, from this block V4 V5 V6, V4 V5 V6, we have V4 V5 V6. Okay, V4 is connected to V5, V5 is connected to V6, and V6 is connected to V4. Okay, so these are the two blocks of the total graph. That means it is a disconnected graph. Okay, so using adjacency matrix, we have also proved that the two graph is isomorphic. So two graphs G1 and G2, we write the theorem here. Two graphs G1 and G2 are isomorphic if and only if the adjacency matrix of one is obtained from that of other by interchanging the two rows and columns. Okay, so okay, now if we prove that two matrix is a two graph is isomorphic or not, say we have a graph, this one. Okay, say it is V1, V2, V3, V4 and V5. Okay, and we have another graph, say it is G1. We have another graph, U1, U2, U3, U4, U5. Okay, so from these two graphs, if we find the adjacency matrix of G1, say it is G1 and it is G2. That means from these two graphs, the adjacency matrix of G1 is V1, V2, V3, V4, V5. V1, V2, V3, V4, V5. Okay, so here it is, V1 is connected to V5 only, V2 is connected to V5 only, V3 is connected to V4 and V5 only, and V4 is connected to V3 and V5. V3 and V5. V5 is connected to V1, V2, V4 all. V1, V2, V3, V4. Okay, so this is the adjacency matrix of G1, and G2 is this. U1, U2, U3, U4, U5. Here U1 is connected to U4 and U5. U2 is connected to U5 only. U3 is connected to U5 only. U4 is connected to U1 and U5 only. U5 is connected to all. Okay, this one. So from xg1 we interchange first and third row. So we get x1. So x1 is equals to first and third row. That means 1, 2, 3. This one. Okay. This. First and third row. Yeah. Again interchange first and third column. First and third column. Okay. So we get third column. That means this one. Then this. Okay. This. Now see here. Say it is x2. See here x2 and xg2 both are same. Okay, so that means we can easily find that that xg2 is obtained from xg1, which is identical to xg2. That means g1 and g2 G1 and G2, what is find here? The matrix xg1, we obtain the xg2 matrix from xg1. Okay, and that is identical to xg2. That means g1 and g2, the two graphs are isomorphic. Okay, so x2 is identical to xg1. That means G1 and G2 are isomorphic. Okay.